Hello guys, I hope you have already tried the problems from the review by yourself. Let us solve them together now. The first problem is the graph problem. So I will ask you several questions. The first of them, determine the degree of every vertex below. So I won't ask you about every vertex, just 4 of them. In this example, we have A, B, C, and D. So the vertex A is here. The degree is the number of edges or lines that end up at A. So you have here 1 and 2. 2 lines, so the degree is 2. The degree of the vertex B is here. There are 1, 2, 3 lines, so the degree of B is 3. The degree of the vertex C, 1, 2, 3, and 4. We have 4 lines, so the degree is 4, and the vertex D. Vertex D has only 1 line, so the degree of the vertex D is 1. How many edges does the graph have? 1, don't skip 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 edges in this graph. Does the graph have any bridges? So remember, bridge is the line, the edge that being removed make the graph disconnected. So disconnected is something like this. Yes, so if it were an edge here, AB, then removing this edge, we get B disconnected from the rest of the graph. We have this situation here, the line BD. If we remove this line, then D will be disconnected from the rest. So the line BD is a bridge, and we write yes here. So if D would be connected to E or to G, it's not a bridge anymore. Okay, can the graph be traced? Try it yes or no. Okay, we remember the Euler theorem. If the graph has 2 or 0 odd vertices, then it can be traced. So we have to count odd vertices on this graph. D has degree 1, so it has only 1 line coming to D. Then B, 1, 2, 3, B is also an odd vertex. A has 2 lines, so it's even. C has 4 lines, E has 4 lines, G has 2 lines, E has 2 lines, H 2, F 2, 4. So all the rest are even vertices. So we have 2 odd vertices. It means our graph can be traced. And the answer for the last question will be submitted on paper with the last problem when you take the photo of your shown work. So yes, it can be traced. Then we must give the Euler path showing how we trace the graph. Yes, so and this path must start at one odd vertex and end at another. If there are 0 odd vertices, that will be one of these 10 variants. Maybe have 0 odd vertices, then you can start at any vertex and finish at the same vertex. If there are 2, then you start at one of them, finish at another. You can start at B, finish at D, or start at D, finish at B. Okay, if there are more than 2 vertices, you cannot trace the graph. You must write it by this point that there are more than 2 odd vertices. The graph cannot be traced. But here we can trace this graph. Let us start at B. From B, we will move to A, then to C. There are a lot of different ways how to trace the graph. B, A, C, E, G, I, H, E, F, C, B, D. We can repeat a vertex, but we cannot repeat an H when we trace the graph. We start at B, the first odd vertex. We finish at D, the second odd vertex. The second problem is syllogism problem. Draw an Euler diagram proving that syllogism is invalid. So it is already known that the syllogism is invalid. We must show this by Euler diagram, Euler diagram. So all trees are green, some frogs are green, some frogs are trees. So I recommend you to start with the premise containing all, because we have only one way how to show this situation. All trees are green means the total circle with trees must be inside of the circle for green things. This is the first premise. The second premise, some frogs are green. Some can be represented differently, so it can be partially overlapping with green, or completely overlapping inside, or including green things. So we must show the second premise so that the conclusion is not satisfied. Some frogs are trees. It means we draw the circle for frogs so that it does not touch trees. So the premises are satisfied, the conclusion is not. We prove that the syllogism is invalid. Another variant, it is known that syllogism is valid, prove it by Euler or Euler diagram. All flowers need water. Roses are flowers. Roses need water. Okay, we also start with all because there's only one way to show it. All flowers must be inside the circle for things needing water. The second premise, roses are flowers. It means that it is actually the same as all roses are inside flowers, and it is only one way to show this. We have only one way to show the two premises, and we can see that roses need water is also satisfied. So this picture shows that the syllogism is valid. The next problem, consider the complete graph. Find low-weight Hamilton circuit by using nearest neighbor algorithm. Beginning at vertex D, so it can be any other vertex. So here we have D. So we start from D, and then we choose the nearest neighbor of D. So we have 4 lines. The weights are 8, 13, 7, and 2. So looking from D, we have 4 choices, and the best choice is, of course, D, E. It is very helpful actually to make such a sketch here showing how we move. We move D, E, because it is easy to skip a vertex when you don't have this image in your head or on your paper. So we move D, from D to E. From E, we have 3 choices. 4, 1, and 9. Of course, 1 is the lowest number, so B is so-called the nearest neighbor, the shortest distance from E to B. We go to B. From B, we have only two choices, go to A or go to C. So we have this way. We cannot return to D or to E. Yes, the circuit must consist of 6 vertices, so 5 vertices, and we return back. Okay, 5 is the lowest number, so from B we go to A. And actually from A, there is only one way how we can finish this circuit. Go to C and return to D. Last vertex is also always the same as the first. And then we want to find the weight of the circuit. Yes. So when we start from D, we first have 2. Then from E to B, it was 1. From B to A, the weight of this edge is 5 plus 5. Then plus 3. And the last one plus 8. We add them together. So this is 10 plus 9, 19. The weight of this circuit is 19. The next problem, determine whether the statements are equivalent using truth tables. So all truth tables start on the same way. So P and Q, T, T, F, F for P, T, F, T, F for Q. So, and we have two statements. First statement is if and only if P, then not Q. So we need a column for not Q. Not Q. And then we can find if and only if P, then not Q. Not Q is the opposite of Q. So we look at the column for Q and write the opposite. If T, the opposite of T is false. False, T, true. True, false, false, true. Then the next column, if and only if P, then not Q. This time we compare this column and this column. In every line we look if the values are the same, then biconditional is true. In the first line, we have T and F. They are not the same. Biconditional is false. T and T, true. F and F, they are both the same. So biconditional is true. And in the last line, false and true, they are different. Biconditional is false. The second statement, P or not Q. We also compare these two columns. This time we have or. Or is true if at least one is true. So in the first line, P is true, so or P or not Q is true. In the second line, both P and Q are true, so the or is also true. In the third line, both are false, the or is false, and in the last line, not Q is true, so the statement is true. So this is the final column for the second statement. This is the final column for the first statement. They are different. It means that the statements are not equivalent. On the exam, a statement can have any possible operator that we learn. So if and only if then, or, and, or negate. So every statement will have a negation. So, but the statements are really short. Okay, we move on to the next problem from financial mathematics. And the first problem is Jane deposits $12,000 into an account paying 7.5% annual interest compounded monthly. How much will be in the account after 12 years? So we have a simple compounded interest formula. P principal is 12,000. Annual interest rate is 7.5%. Oh, we need it in decimal form, so we move decimal point 2 places to the left, 0.075. The interest in compound monthly, so M is 12. If it is compounded quarterly, then M will be equal to 4. It can be also. And then we have time T, 12 years. Time is always in years. Then we just substitute these numbers in the compound interest formula. If you use a hand calculator, you first find R over M, 0.075 over 12, and 12 times 12. And then you substitute the rest in the formula. So 0.075 divided by 12 0.00625. Do not round it too early. Don't use 63 here or 2 digits instead of 3. Okay, then with plus 1, the sum is raised to the power 144, and then the total is multiplied by 12,000. The amount after 12 years will be 29,432.60. So the last digit is 8, but the next digit is 5, so we round up 69 cents. The next problem is unpaid balance method. We have a credit card account. We take the last month's balance, which is 875, add the finance charge for this month or based on the last month's balance of 875 times interest rate divided by the number of compounding periods, so 0.18, of course in the decimal form, and divided by 12. By unpaid balance method, we always have RT is 0.18 over 12, so annual interest rate divided by 12. So this is the final charge for this month, or based on the previous month's balance, and this is the answer for the point A. On the second exam, many students have forgotten about, to finish this problem, forgotten about the second and the third step. So that's why I separated this step. So first you find the finance charge for this month based on the previous month's balance. Then you find the balance for this month. And then you find, so many students have forgotten this last step. Then you find the finance charge for the next month. So that based on this month, that will be on the bill for the next month. Okay, this is the first step. Then we find the balance. Here you must look whether it is with plus or with minus. So if it is a refund, it means it is returned to your account. Your debt is less now. So we subtract 68, then charge 35. plus 35, charged 127, refund, so subtract 150, charged plus 23, plus 16, and plus 13. And usually there is also a payment. So here in this example, there's no payment. If there is a payment, then you also subtract payment. This will be the balance, the finance charge for the previous month. So then we find the balance. 875 plus answer from the previous step minus 68 plus 35 plus 127 minus 150 plus 23 plus 16 plus 13. The balance at the end of the month is 884.13. We round to the nearest cent. We find the finance charge for the next month, and it will be the answer from the previous step multiplied by 0.18 annual interest rate divided by 12. So for the next month, it will be $13.26. And the third problem to chapter 3, to financial mathematics, Henry takes out an amortized loan for $25,000 to buy a motorbike. The loan has an annual interest rate of 18% compounded monthly, and he will be paying it off in monthly payments over 10 years. What is his monthly payment? Amortized loan formula has two parts. On the left, we have principal, the present value, times 1 plus r over m raised to the power mt. On the right, we have regular payment that we want to find here, multiplied by the same factor, 1 plus r over m to the power mt minus 1 divided by r over m. Here the present value, the value of the loan at this moment is 25,000. Interest rate is 0.18. Compound monthly means m is 12. It is ordinary. So the compounding is the same on the left and on the right. And we need also time, 10 years. T equals 10. Now we substitute the given values in the formula and solve it for r. 25,000 times 1 plus 0.18 over 12. 12 times 10 equals r times 1 plus minus 1 divided by. So first we need to find 0.18 over 12. R over m is 0.015. Then we find this factor plus 1 raised to the power 120. We can also multiply it by 25,000 to find the left side of the equation. 149 to 33 point. So, and the right side of the equation, we must subtract 1 and then we divide by R over M, which is 0.015. So we got an equation. This equals R times 331.28819. So to find R, we must divide by 331 on both sides. So the regular payment will be approximately $450.46. Suppose that University of East and West Texas has 4 colleges: humanities, natural sciences, veterinary science, and education. The distribution of faculty members across the colleges is given by the table. Assign representatives from the 4 colleges to a 15-member faculty senate. We have 2 ways how to use Hamilton method. So the method that we studied in the beginning of the chapter, and the second method that we studied in the end of the chapter with standard divisor. We'll use the method with the standard divisor since it's easy to use. So first we need to find the total population. So the total is 188 faculty members. And we divide 188 by the number of seats in the faculty senate, by 15. And it will give us the standard divisor, 1253. Then we want to find exact quotas for every college by dividing the number of faculty members. For humanities, it is 54 by standard divisor. So the standard quota for humanities is approximately 4.31. We usually don't need more than 2 digits after the point. For natural sciences, we divide 73 by standard divisor. And get 5.82. Then for natural sciences, 37 divided by standard divisor is 2.95, and education, 24 divided by standard divisor is 1.91. By Hamilton method, first we assign the integer part, or so-called lower quarter. So we assign 4 for humanities, 5 for natural science, 2 for veterinary science, and 1 for education. And define the sum to see how many extras we have. 4 plus 5 plus 1 plus 2 will be 12. 12 from 15, so we have 15 minus 12, 3 extras. And they will go to the colleges with a greater decimal part. So the first goes to veterinary science with 95, the second goes to education with 91, and the third goes to natural sciences with 82. The final distribution will be 4, 6, 3, and 2. If you add them together, they're exactly 15. So this is the apportionment according to Hamilton method. The next problem is about constituencies. We have two states, you know this problem from the second exam. Let us consider two states, Ohio and Colorado. Ohio with 11,689,000 and 16 representative. The average constituency is the fraction 11,689 divided by 16. So this is approximately 730.6 or 0.56, but 5 is rounded up. So it is approximately 731. Average constituency of Colorado is 823. Also, we round up because the next digit is 7. Absolute unfairness is the difference. 823 minus 731, 92. And the relative unfairness, we take this difference, the absolute unfairness, 92, and divide by the smallest unfairness by 731. So the relative unfairness here, it is relatively big, 0.126. So the next digit is 8, that's why we round up. 0.126, but often it is so small that the first two digits are zeros. That's why we need to round to 3 decimals in this part. The next problem is about voting. So here we have an example from the spring exam. The Lubbock Area Monster Movie Appreciation Society has decided to watch a classical vampire movie at their next meeting, tentatively scheduled for Halloween. The choices are Nosferatu, Dracula, and Vampire. The table below lists the ballots cast, and the question is, which movie will the Lubbock Area Monster Movie Appreciation Society watch? According to the plurality and according to plurality elimination method. So I've sent you this first table, but this table gives the same result for both methods, plurality or plurality elimination, because by the first trial, one of the candidates has already the majority. Let us determine the majority for this table. So we add the ballots, the voters. 4 plus 5 plus 8 plus 2 is 19. 19 divided by 2 is 9.5, so the majority is 10. So we have Nosferatu having 9 votes, Dracula having 10 votes. So Dracula is winning by plurality, and also by plurality with elimination, because the weakest candidate even didn't get this first votes, and Dracula has already majority on the first step. Okay, let us adjust the table. So let us find the majority for this table. We add the votes. 4 plus 5 plus 8 plus 2 plus 8. It is 27. We divide 27 by 2. It is 13.5. So the majority is the integer greater than 13.5 is 14. So we will eliminate candidates until one of the candidates get the majority. So on the first step, Nosferatu N has 9 ballots in his for him, and Dracula has 10 ballots. It is now less than majority, and Vampire has 8. The Vampire is the weakest candidate, so we eliminate V from the table. Then N moves up to the first place. And on the second step, N has 9 plus 8, 17 votes. D has still 10 votes, so N with 17 votes wins by plurality with elimination. Okay, let us fill out the answer boxes. First, plurality, it was Dracula. D wins by simple plurality with 10 votes. On the second step, N wins by plurality with elimination with 17 votes. Okay, next question. The weighted voting system. So we have 4 voters, A, B, C, D, in that order. So this is A, this is B, this is C, this is D. And the first number is the quota. So first question, what is the quota? So, and this is 12. Second, what is the weight of voter B? So just to check that you understand what does it mean here. So the voter B is here, its weight is 5. So the second part of this question must be answered on paper, because it is hard for computer to recognize your answers for this part of the question. What are the winning coalitions, and what are the critical voters in these coalitions? So we have 4 voters. We have 1 member, 2 member, 3 member, and 4 member coalitions. So 1 member are not winning coalition, but 2, 3, and 4 member coalition can be winning. Let us start with 2 members. So let us first list them all so that we don't forget any of the voters. So A, B, A, C, A, D. Then starting with B, B, C, B, D, and C, D. 3 member coalitions, A, B, C, starting with A, B, there is another coalition, A, B, D. Then still starting with A, C, D, and one that started with the B in the beginning, B, C, D, and the last is A, B, C, D, 4-member coalition. Now let us find their weight and determine whether they are winning or not. A plus B, 4 plus 5 is 9, is less than 12, so this is not winning. A plus C, 4 plus 6 is 10, the weight is 10, is less than 12. A, D, 7 plus 4, 11, is still less than 12. B, C, 5 plus 6 is also 11, not winning. B, D, 5 plus 7 is exactly 12, so it is the first winning coalition in this list. CD, 6 plus 7 is 13, so it is also a winning coalition. ABC, 4 plus 5 plus 6, 15 is winning. ABC, 4 plus 5 plus D, is also winning coalition. Oh, sorry. plus 7 is also winning. ACD, 4 plus 6 plus 7, 17. BCD, 5 plus 6 plus 7, because it is a winning one. And ABCD, 4 plus 5 plus 6 plus 7 is also a winning coalition. Okay, we have 7 winning coalitions. We want to determine the critical voter. So it means that when this voter leaves the coalition, it is not winning anymore. In 2-member coalitions, both voters are critical. So both B and D are critical voters. In this, also C and D. In A, B, C, look at the numbers 4, 5, 6. If you remove one of the numbers, even the smallest one, 4, will be 5 plus 6, only 11 is less than 12. It's not winning anymore. So every voter is critical in this coalition. The next, A, B, D. Even if you remove A, 5 plus 7 is 12. Okay, it means that A is not critical, but if you remove 5 or 7 from this sum, it will be less than 12. So B and D are critical in this coalition. ACD, if you remove 4, 6 plus 7 is 13, greater than 12. So A is not critical, but both C and D are critical. In the last 3-member coalition, if you remove the smallest voter, 6 plus 7 is still 13, but if you remove 6, 5 plus 7 is 12, but if you remove 7, 5 plus 6 is 11. So 7 or D is the only critical voter in this coalition. And the coalition A, B, C, D, even if you remove the the heaviest voter, 7, is still greater than 12, so none of the voters is critical in the last coalition. Okay, this is the list of critical voters, and we move on to the next problem. The next problem is from probability chapter, and we need to draw a probability tree to answer this question. So the probability tree must be submitted with the shown work with the last problem. Okay, the supermarket is selling chocolate eggs containing small toys. Half of the eggs are milk chocolate, half of them dark chocolate. So our first step, we have the half, 50% or 0.5 on milk chocolate, and another 0.5 is dark chocolate. Second step, or second stage, 70% of milk chocolate eggs contain a toy car. 70% is 0.7 in decimal form. So toy car. The rest is 0.3, contain a superhero figure. And the similar two branches for dark chocolate eggs. So here we have 40% with toy car. So the rest is accordingly 0.6, 60% with a superhero. What is the probability that you pick a milk chocolate egg? Um, uh, you will have it was the old spring problem, so you will have it a little different. So to find to answer the third question, you need to answer two first questions. What is the probability that you pick a milk chocolate egg with a toy car? It means we are on the first branch of this tree. Milk chocolate, toy car. Probability of this outcome is given by the product of two probabilities along the branch. 0.5 times 0.7. 0.5 times 0.7, 0.5. So 5 times 7, 35, and we move decimal point 2 places to the left, so 0.35. We want to give the answer in percent, so 35% is the probability of getting chocolate egg with a toy car. What is the probability that you pick an egg with a toy car? There are actually two ways to get a toy car, either with dark chocolate or with milk chocolate. Yes, so it means we must add these two probabilities. So probability of a toy car with that in dark chocolate is 0.5 times 0.4. We multiply the probabilities along this branch. The probabilities that we are interested in is the sum of these two. So 0.35 is the first one, plus this product. 0.35 plus 5 times 4 is 20, and we move decimal point 2 places to the left, 0.20. So we get 0.55, or in percent, it will be 55%. You pick a chocolate egg at random and discover that it contains a toy car. So this is given. What is the probability that you picked a milk chocolate egg? So the probability, find the probability of milk chocolate given that you have a toy car. So toy car, these two outcomes from the part B. And the probability that you get toy car and milk chocolate is this one. So the probability of the event in favor is 0.35 divided by probability of this new sample space that it is a toy car is 0.55. So this is from part A, this is from part B. And the probability, this conditional probability is 0.35 divided by 0.55 is 0.6363, or in percent 63.6. So the question will be around to the near to 1/10, so 63.6%. Another probability problem. Assume that two cards are drawn from a standard 52 card deck. Find the following two probabilities. Assume that the cards are drawn without replacement in the part A and with replacement in the part B. We want to find here the probability of drawing two non-face cards. Let us recall what the deck consists of. So we have 52 cards, 4 suits. So face cards are jacks, or 4 jacks, 4 queens, and 4 kings. So 3 times 4, 12 cards. So non-face cards are 52 minus 12, 40 cards. So the probability of the first non-face card will be 40 over 52. Part A, without replacement, it means that by the second drawing, we have only 39 non-face cards and only 51 in total. The probability that we are asked to find is the product 40 over 52 times 39 over 51. Point 58, 52, so the answer must be given in percent, so 58.82%. The second situation, part B, we draw the cards with replacement. So the first card, the probability is 40 over 52. We take one card and then we return this card to the deck, so that by the second drawing we have the same 49 non-face cards in the deck of the same 52 cards. So the probability will be the product 40 over 52 times 40 over 52. Point 5917 or 59.17%. The next problem, consider the following game of chance. A card is drawn from a standard 52 card deck. A player must pay $20 to play the game, which must be subtracted from the winnings. If a jack or queen is drawn, then the player wins $60, otherwise they lose their $20. So we have only two outcomes. So the first outcome, winning, so the expected value will be probability of the first outcome times associated value plus probability of the second outcome times associated value. The first outcome is winning, then you get $60, but we must subtract $20 that we paid for this game, so $40. The probability of winning is, so jack or queen, so we have 4 jacks, 4 suits, and 4 queens from the total of 52 cards. So 8 over 52, or we can divide by 4 will be 2 over 13. The second outcome is losing. The associated value is -20, you lose $20. The probability of losing is the rest of the card. So if it is not jack and not queen, so 52 minus 8 winning outcomes divided by 52. So 44 over 52, or you can simplify dividing by 4, 11 over 13. And now let us write the formula for expected value. 40 times 2 over 13 minus, so this minus, we have negative value, 20 times 11 over 13. So you can calculate it calculator or just simplify it a little bit. So 80 minus 220, so negative. Let us take the calculator. Negative 10.77. So the next digit is 9, so we round up. So $10.77. So we have you'll have 3 questions here. First, calculate the expected value. It is negative 10.77. Second, do you expect to win or to lose? So it is negative. It means you lose by this condition. You expect to lose. And let's calculate the price that would make the game fair. So if you pay $20, you expect to lose on the average $10.77. So if you would pay this number less, so 20 minus 10.77, then the average, the expected value must be 0. So the fair price for this game must be $9.33. The next question is statistics question. So find the range, mean, median, and mode of the data set. To find range, median, and mode, we first need to arrange data. So, and be careful here, you should write every digit, so be careful. So we have 6, we have also 5, 13, then 14, 14, and another 14. And I see now that I skipped 10. So 26, oh, we have 24 first. 24 and 2 times 26. And we must add 10 here. So, and let us check that we have all the numbers. 5, 10, 15, 19, 19 numbers. And let us check it here. 5, 10, 15, 19. So we have all 19 numbers here. Now we can easily find the range of this data set. We take the first number and the last number. 26 minus 5, 21 is the range. To find the median of the set, we need to find the middle of this arranged data. So we have 19 is 9, 9, and 1. So let us go 9 numbers from the left, 9 numbers from the right, and we have 18 in the middle. So the median is 18. If there are even numbers, So for example, 18 and 19 are in the middle. In this case, the median will be the mean of these two numbers. Yes? But it's not the case in this example. To find the mode, we'll also look on this range list of values, and we see that we have repeating values 14, 19, 21, 26, but the values that occur most frequent are 14 and 21. So in this example, we have two modes, 14 and 21. And also don't forget the mean. To find the mean, we must add all these values. We can take the arranged sequence, or we can take the original one, add them together. Add them together, then divide by the number of values by 19, and then we get the mean of the set, 16.63, or if we round to approximately 16.63 if we need two digits, round to two decimal point, two digits after the point. And the last question here, we have a normal distribution with a mean of 60 and standard deviation of 5, and we will use the rule for 68, 95, 99.7. Our distribution has a mean at 60 and has a bell-shaped form, which is standard for all normal distributions. It has 68% of values within one standard deviation. So one standard deviation is 5. So 60 plus 5 is 65, 60 minus 5 is 55. Then plus 1, one other standard deviation plus 5 will be 70, and one more time plus 5 will be 75. And to the left, 55 minus 5, 60, two standard deviations from the mean, and minus 5 one more time will be 45. So the first question is the percentage of values in the distribution between 60 and 65. 60 and 65. So one standard deviation, but only to the right from the mean. So this is the half of 68. 68 divided by 2, 34%. The second question, the percentage of values between 45 and 75. 45, 75. 45 is 3 standard deviation to the left from the mean. 75 is 3 standard deviation to the right from the mean. So this is the number, the third number in this rule, 99.7. 99.7% of data value fall between 75 and 60 and 45. Okay, that's all. Please read carefully what is written in the problem, what is asked in the problem. Don't forget to upload your shown work. The shown work must be in PDF only. So if you don't know what kind of a file you have, use the link provided in the last problem to combine PDF. Combine your pictures into one file and upload them. So if you have any questions, please email me. And I wish you good luck on the exam.